Hi everyone, hope you're all doing well. So I'm back again with another video about linguistics. So today, in this short video, I'll talk about the what I think is the relevance of linguistics and speech technology. And I'll actually, so this is my understanding of the history of speech recognition and speech technology. So yeah, so to start with, I'll add a disclaimer here. So parts of it might feel like a rant uh, because all these thoughts have been on my mind for a long time, and I've kind of, you know, wanted to channel that energy into a video. So you might feel some of that pent up energy coming out. So I hope you don't mind that. But yeah, so a little bit about the title of the video is I have a provocative title for this video, which is Has linguistics contributed anything at all to speech technology? So the reason I have the title is because of I was actually asked this question a few times. So to give you some context, so I'll share an anecdote here. So in 2019, I was presenting a paper at a conference, and it was a paper on how to use knowledge of phonology to improve speech technology. So I was arguing that you can use knowledge of phonology to kind of improve speech technology. And there was a professor in the audience who and they said this is the first time that they actually are encountering this notion that knowledge of linguistics can actually help speech technology. And I thought to myself, okay, something that's so obvious to me is not, it doesn't seem to be obvious to others. So fine, I mean, I just took that remark in my stride and I moved on. Then I heard that again a few, it was almost like a few months later. So from another person in academia who said the same thing, that yeah, how is linguistics useful? Has it helped you at all? So yeah, and in the real world, people don't know much about linguistics. They think it's about general perception is it's about pronunciation, or it's about grammar, or it's about speaking in the right way, etc. So I mean, and I don't mean this in any sort of dismissive way. So, I mean, if you're a language teacher who's teaching pronunciation, who's teaching languages, then that's great. It's a very important thing, but that's not what linguistics is about. So, linguistics is it's about like, studying the structure of languages, and it's about like understanding the principles underlying human language. So, it's kind of different slightly. So yeah, so in this video, we'll talk a little bit about how knowledge of linguistics can help you transition into speech technology. So yeah, so the target audience for me is students of linguistics who have gone through a linguistics program and who have knowledge of phonetics, phonology, and all these related topics, and they are wondering like what they can do with their skill set in the industry. So I want to give you some context by relating my own personal journey. So throughout my education, in whether it's bachelor's or the master's degrees that I did, I always worked on NLP. I never worked on speech. So I had quite some experience of NLP, but I never had any hands-on experience with speech. So I mean, the closest I came to speech was like working on vowel harmony in Telugu, and for which I had to do some fair bit of phonetic analysis and Prat. And also, yeah, I mean, just like uh, fitting a linear regression model, or like, I mean, yeah. So it's very basic stuff, nothing directly related to speech technology. And I took one speech recognition course, speech processing course, which was years ago in 2000, yeah, around 2009 or something. So this was at IIIT Hyderabad, and I still remember the lectures by Professor Narayana. He had a lot of DSP, digital signal processing, and I mean I could understand the basics, but most of the rest, like the uh, poll analysis, etc. All of that went over my head because, yeah, basically, I mean, I wasn't interested in that sort of, that sort of area, but I took the course to kind of get some exposure and to know the basics. But apart from that, I never really worked on speech. So in 2018, I was actually, I went through a rough period of unemployment. So I was like, unemployed for almost, as in, I didn't have a proper job. I was doing things on the side, like I was kind of tutoring, teaching people how to code, and helping people build their thesis projects, etc. Um, and yeah, so at that time I was kind of this was all in Dublin, Ireland. So yeah, I had applied to jobs, and my profile was an NLP engineer. So that's what I knew, and I thought, okay, I'm going to find something in that area. But then, once I realized that okay, there aren't enough jobs in this area, then I kind of expanded. I decided, okay, I'm going to venture out of my comfort zone. I'm going to try to apply for jobs with speech. So I applied to a job which was for a speech recognition engineer at a company at a kind of a small sized company in Dublin, and they were kind enough to give me the opportunity to work for them. And they were actually building an app for uh, automatic transcription of clinical dictation. So doctors would give dictation into the app, and the app would kind of transcribe the uh, transcribe the dictation using speech recognition, and then we would use some NLP to kind of correct the transcript and structure it into a clinical document. So yeah, it was very exciting sort of work, and the first few weeks of the job was basically, so as I mentioned, I knew very minimal speech technology. I knew a little bit about grapheme to phoneme conversion and these sort of things which I had been working on. And these are things where it's sort of, it's not really it's a more general problem if you're working on even like if you're a linguist and you're working with a language which doesn't have a Roman script, then you want to kind of have some sort of phonetic transcription. So this was a general problem that I was working on. So I knew a little bit about grapheme to phoneme conversion, but not so much about the actual core algorithms that are used in ASR and TTS. So the first few weeks of the job, I was looking at language modeling because I knew about language modeling a little bit from my work on machine translation. So yeah, I mean, like there are various ways of improving language models by adding more training data, by tweaking the training parameters, and also the tuning, the pruning of the language model, etc. So the first few weeks I was doing these things, and on the side I was studying about speech technology. So at that time I kind of wanted to do some broad reading on the history of speech technology. And so whatever I'm going to share now is from those from that period, and also from other things. Over the last 3 years I've been kind of working on speech. So everything sort of informs what I'm going to say. So if you look at the origins of speech technology, my argument is it derives a lot of inspiration from work on phonetics and phonology. So if you look at the some of the original models in speech technology, like for example Gunnar Fant's source filter model, right? So the source filter model, I won't get into too much detail, but the source filter model is a kind of a model which, so they are trying to model the human vocal tract. And so the idea is that the source is the vibration of the vocal folds, and the filter is the shape of the acoustic shape of the vocal tract, which sort of distorts the signal produced by the source. And so yeah, a little bit of again some historical context. So Gunnar Fant is actually a Swedish electrical engineer. So he is considered one of the pioneers in speech technology. So he's from, I guess he's from KTH in Stockholm. but he spent some time at MIT where he met Roman Jakobson. So Roman Jakobson, the linguist, will know that he is one of the legendary linguists. So he was from Russia, from a Jewish background, and so during the World War he kind of fled. So yeah, his family probably moved from, I don't know all the details, but I know that he was associated with the Prague School of Linguistics. And then after the turbulent, the wars in like the 30s and the 40s, I think at some point he moved to the US, and he was working at MIT as well in the 50s, I guess. And that's where like Gunnar Fant and Roman Jakobson met, and they started, Jakobson came with all of this background in linguistics, and he knew about so many languages, he knew so many things about the structure of language. And Gunnar Fant was an electrical engineer, so they worked together, and that's where the source filter model was developed. So basically, the source filter model applies techniques from mathematics, like the Fourier transform. So you can actually do Fourier analysis of speech to identify the source and filter characteristics. So the So yeah, so when you talk about Fourier analysis, so yeah, maybe I'll do a subsequent video. I'm actually planning to do something with Prath because most linguists are familiar with Prath. So probably my next video will be all about how to get into speech technology using Prath, just Prath. So with Prath, you can learn a lot of things. You don't need any other tool. With just using Prath, you can learn a lot. So yeah, anyway, coming back to this idea of like the source filter model. So what Gunnar Fant showed was if you treat speech sounds. So if you, for example, let us take the simplest case. So let's look at the case of a vowel, right? So when you take a vowel, vowel is a periodic sound. So there is a like a periodic element. So it involves the vocal folds vibration, which produces a periodic wave. So it's a voice sound, right? But then it's a complex wave. It's not a simple wave. Simple wave is like is like an ideal approximation, like a sinusoid with a fixed period, right? But a complex wave is usually like a combination of various simple waves. And when you have a complex wave, so yeah, we'll get into these basics. And there is also, I'm going to suggest some reading material. So I think, yeah, Johnson's textbook on acoustic and auditory phonetics is really good, and I am reading it too these days to kind of refresh my knowledge of these things. But yeah, the idea is that this whole notion of identifying the source characteristics through mathematical analysis of the speech signal is something which developed because of the confluence of linguistics and engineering. So and specifically, so my argument is specifically like the Prague school that Roman Jakobson was from. So if you look at the history of linguistics, if you look at the history of phonetics, right? So the Prague school is kind of different, had a different take compared to the American schools of linguistics like structuralism, etc. So they assume that the phoneme is the minimal unit of speech. So there is a lot of discussion of what is an allophone, what's a phoneme. So the work of KL Pike, the work of Maurice Swadesh, and all of these structuralists, American structuralists like Bloomfield. So all of them, right? So they assume that the phoneme is the minimal unit of speech. And in the Prague school, they actually assumed that it's not the phoneme, and they actually saw the phoneme as a cluster of, as a bundle of distinctive features. So they saw like the distinctive features as the minimal units of speech. And my feeling is, I mean, like, it's not my feeling. I actually, you will not see this anywhere because everyone sticks to the conventional narrative. But if you look at the Prague school was heavily influenced by the Indic tradition of linguistics. And if you look at like the ancient grammarians from the Indic tradition, so like if you look at Panini's grammar, Panini has a very neat organization of the speech sounds of Sanskrit based on features, articulatory features. So the names that you have, Murdhanya and Talavya, and all the features that we study when we study Sanskrit grammar in school. So all of those are basically, if you just translate them, they are like palatal, dental, nasal, and things like that. So they already had that notion that distinctive features are more primitive than phonemes. So multiple phonemes can share the same distinctive feature. So distinctive features are even more, low level descriptions of the speech. And and the source filter model sort of builds on that idea. The source filter model takes these basic articulatory gestures. The goal of source filter model is to apply Fourier analysis to identify these basic source characteristics and filter characteristics. So for example, if you have so this the whole notion that if you have a periodic wave, then if you take the power spectrum, then you will see impulses at like the major components of the wave. So for example, if you take a vowel like ah, right, if you take the power spectrum of that vowel, so you will see the in the spectrogram, you will see the energy bands at the formants, and those formants correspond to different articulatory gestures. So for example, uh, f1, right? So f1 has a particular significance. F2, if I recall correctly, is related to backness. So and then f1 is inversely related to height, I guess. So yeah, the higher the vowel, the lower the f1, and so it's basically related to openness. So all of these things were built. So my argument, yeah, I want to finish it quickly because I don't want the video to be too long. But the main argument that I make here is based on my reading, which is very limited. Most of the foundational ideas of speech technology, whether it's speech synthesis or whether it's ASR, they come from, they're inspired by linguistics. And yeah, so and the other thing that I wanted to mention is the International Phonetic Alphabet. Without the International Phonetic Alphabet, we would never have been able to classify the sounds, identify. So all of that was decades and probably even like centuries of work. And speech technology is built on those foundations. So if you're a linguist, don't think that your skills are irrelevant to speech technology. And there are various ways in which you can use all that knowledge to get into speech technology and to actually, do novel things, do creative things, not just, tread in others' footsteps. And if you're an engineer, if you're a machine learning engineer, I would suggest that you read about the basics of speech and also this history of speech. So what is like source filter model, and what was what's the notion, what's the intuition behind the source filter model, and things of that sort. So anyway, so I think this is good enough content for this video. And yes, if you haven't subscribed to my channel, do that, because as I promised, I'll create more content in the weeks and months to come. And I hope you have fun exploring, if you're a linguist, exploring language technology, and if you're an engineer, explore some linguistics. So it will kind of make you develop a richer perspective on language technology. And until the next time, bye and take care.